As per your request, here is solution of a test problem from IB test paper. Thanks for your generous contributions. They help us provide you with free services. We have been doing so for last 15 years. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking a very important question from past test papers. It is based on students taking IB Math HL. Let me thank all the viewers and subscribers for watching my videos. They have been absolutely free for last 15 years and we have more than 17,000 videos at present every day uploading a video on an average. Well, in case you want to learn from me directly, send an email to globalmathinstitute@gmail.com. We can be part of your success story. The question here, as you can see, is the diagram below shows a sector AOB of a circle of radius 1 and center O, where the angle AOB is equal to theta. The lines AB1, A1B2, A3B3 are perpendicular to OB, right? These lines are all perpendicular. A1B1 and A2B2 are all arcs. So these are the arcs of the circle with center O. Part A of the question is calculate the sum to infinity of the arc lengths AB plus A1B1 plus A2B2 and so on. You can always pause, answer the question, and then look into my suggestions. We can definitely provide you with a solution, but before that, as I normally do, let's look into the concepts and try to solve it using the concepts. So what we need to really prove that these arc lengths, right? These arc lengths, their sum is what we need to find basically. And you know what is arc length? If A is the arc length, is equals to R times theta. Theta is constant here, right? So basically, the whole expression of this arc length boils down to the series. We are trying to find the sum of this, right? So where theta is constant and radius is OA, OA1, OA2, and so on. So we could write this as theta times O2 AI. You get the idea. Where it will be like A0, we can start, right, to infinity, right? So A0, A1, A2, let me write this as A0, initial. And we also know that OA is 1, right? So basically, if you look into this particular question, you can also use cosine ratio. What is cos theta equals to? Cos theta can be written as, if you look at this triangle right there, O2B1, which is the base, over the hypotenuse O2A. A is 1, right? So OB1 is cos theta. O2B1 is same as O2A1, right? So I could write this as O2A1. So what we have done here is we have shown that out of these, this is O2A is 1 and O2A1 is cos theta. And we can continue this process and write down what A2 is. And then we have a solution in hand. You get the idea, right? So I like you to follow the steps which we just talked about and get the solution. Perfect. So, in this particular series, we want to find the sum of arcs. Now, this sum of arcs, let's call this as S, is basically equal to R times theta. So, AB is 1 times theta plus A1B1, which is arc A1B1, is theta is the same, right? Multiplied by OA1 times theta. Similarly, A2B2 is OA2 times theta, and so on. So theta is a common factor here, and we have a series 1 plus OA1 plus OA2 plus OA3 plus so on. And we just now shown you that cos theta is basically equal to OB1 over the hypotenuse, which is OA, and OB1 is same as OA1, right? And therefore, we now know that OA1 is equal to cos theta times OA, and OA is 1, right? Let me write here, OA is 1. So OA1 is cos theta, so I'm writing this as 1 plus cos theta. Get the idea. Now, what is OA2? We can again look into the other triangle, which in this case is this one. Do you see that? Now, here again, we can say cos theta is equal to OB2 over OA1, right? And OB2 is same as OA2 over OA1, right? So from here, we get OA2 as equal to OA1 times cos theta, right? So this becomes equal to cos square theta. You get the idea. Now, if you continue with this, then each hypotenuse which we are looking at is actually power of cos, correct? And this becomes an infinite series. Is this part clear to you? Now, as you know, cos theta is always less than 1. It could be equal to 1, but here the angle is given to us as more than 0, so it is less than 1, and therefore this is a converging series. And we can apply the formula for infinite series, correct? Converging, right? And it's an infinite series. So, what do you think is the result? So, I think it's absolutely clear. So, what we have here is that the sum of all these arcs, right, is basically equal to theta times 1 plus cos theta plus cos square theta plus cos cube theta, and so on. So it can be written as theta into, this is a geometric series. Sum to infinity for a geometric series is a over 1 minus r. A in this case is 1, right? So we get 1 over 1 minus r, in this case is cos theta. And therefore, the result is theta over 1 minus cos theta. Is that clear to you? That is how we can actually solve this beautiful question. You see how many concepts have come together? Your arc length radian measurements, sequences and series, and how do we use the simple concept of SOHCAHTOA to relate different terms and find the solution. I hope you find this interesting and useful. Also, look at many other examples which we have taken from past IB test papers. They are challenging, beautiful questions which can help all of you. In case you want to learn from us, send an email to globalmathinstitute at gmail.com. We do the questions which you need, and this is your website. You may also contribute so that we can continue to provide you with these beautiful free services forever. Thanks for your support and all the best.